While the majority of the rationalizing that we do is related to square roots, the possibility exists that the rationalizing you will need to do for any question could potentially be of a higher index. So here we have two examples of potential denominators that we might need to rationalize. Now, if you use the logic of square roots, it would just say, oh, repeat the exact same radicand and multiply them together. That's what we saw in our other examples when it came to square roots. But in this case of higher indexed roots, and here we have a third root and a fifth root, in the case of the higher indexed roots, it's important to choose your radicand so that it is something that you actually can take that root of. If I just chose root 9x squared y, and I wanted to do my rationalization with that multiplication, and I would get the third root of 81x to the fourth y squared. This x to the fourth term is the only term that I can take the cube root of. There is no perfect neat cube root of 81. 27 goes into it, but it leaves behind a 3. And then y squared, it doesn't even have enough y's in order to make a perfect cube. So we can't just jump right to multiplying by this exact same radical again. We're going to have to be careful choosing our radicand so that it actually will result in a simplification. So we know at least that we need it to be a cube root because we're going to need to multiply them together. You have to look carefully at each one of these parts in order to make that decision. So if I'm looking carefully at the 9, I know that 9 is already 3 times 3. If I want to turn that 9 into a perfect cube, I need to make sure that it is actually something cubed, which means I'm going to need another 3. I look next at the x squared. That's an x times an x. I need to make sure that's a perfect cube. So in order for that to happen, I need another x. And then I look lastly at the y, which is just a one individual y. In order for that to be a perfect cube, I need 2 more y's as part of my product. So you can see it, let's multiply everybody together on the insides, multiplying the radicands. We've got 27x cubed, y cubed, and I can take the cube root of that expression, 3xy. My rationalization would come from a factor like this, not necessarily the exact same thing that I started with. And in case we showed it before we started this, that using the exact same radicand isn't going to work. Same thing with the fifth root. You give consideration to what you have. I've got 3 x's. In order to take a fifth root, I'm going to need 5 of them. So my product is going to have an x squared in it. I need 2 more x's. I look at the y's. I only have 2 so far. I need 3 more of them in order to create a fifth power. We multiply the 2 of them together, x to the fifth, y to the fifth, which simplifies to just xy. You might think these particular multiplications for rationalization are easy. No one is suggesting that it's not necessarily, especially with the variables, easy to find what you have to multiply by. But you cannot just jump to, I'm going to multiply by the same thing that was already the radicand. That only works for a square root. We saw that in our examples for the square roots that you could do that. That's not what's going to happen here. This even applies to those situations where you're going to use the conjugate, which you may or may not have experienced already in this lesson, depending upon the order that you've gone in. You might need to give some special consideration to how you're going to do that multiplication, how you're going to choose that radicand, and how you can choose it so that it will actually simplify with the first radicand that you're trying to rationalize, or the first radical that you're trying to rationalize.